Now in Calc 2, we found the arc length of a plane curve by x of t equaling f of t and y of t being some g of t, and t ranging from a to b, with finding the integral of a to b times of the square root of t prime of t squared plus g prime of t squared dt, which we could also write as dx dt squared plus dy dt squared. Or we simplified it to just the square root of dx squared plus dy squared. And that's where we got this arc length for our curves. Now, we've stepped it up a dimension. So we can do the same thing for curves in R3. The arc length of the curve r of t, which is f of t, g of t, h of t, for t between a and b, is just going to be the integral from a to b of f prime of t squared plus g prime of t squared plus h prime of t squared. Now, there are, of course, some technical assumptions that we make in this formula, that r of t does not cross itself, so like there's no t equaling a and t equaling b besides when t equals a and t equals b. And f prime, g prime, and h prime have to be continuous. For functions that are continuous, we say r is C1, C being for continuous. Now, if you remember, the magnitude of r prime of t is just the square root of f prime of t squared plus g prime of t squared plus h prime of t squared. So the arc length can just be computed as the integral from a to b of the magnitude of r prime of t dt. Hopefully all these connections are starting to come together. So let's look at an example. Find the arc length of r of t being t, 3 cosine of t, 3 sine of t, when t goes between -5 and 5. Well, all these functions are continuous because of what we know from Calc 1. And we're going to just assume for now that there's no crossing, which, don't worry, it's fine because of that t there. T just goes back and forth. No way that t can equal -5 or 5. Yeah, except for when they're -5 or 5. So let's do this. So we need to find r prime of t, which is simply -3 sine of t and 3 cosine of t. All right. Now we just need to find the magnitude of r prime of t, which let's do that by the square root of 1 squared plus 9 sine squared of t plus 9 cosine squared of t. Well, that turns out pretty nicely because we get the square root of 1 plus 9, which is the square root of 10, which is a pretty nice function to deal with. So now, in order to find the arc length, we just need to do the integral from -5 to 5 of the square root of 10 dt, which is equal to the square root of 10t evaluated from -5 to 5. So we are going to get 5 square root of 10 plus 5 square root of 10, which, in other words, is just 10 square root of 10. Pretty simple, right? You know, maybe the function won't be so nice next time, but the steps are just the same.